Hey everyone, welcome back to another video in Node.js Express use case series. In this video, we'll dive into authentication and authorization, two essential concepts for building secure web servers. These concepts apply not just to Node.js and Express, but to web development as a whole. We'll explore different types of authentication, including modern and obsolete methods, as well as various authorization techniques. Whether you are a beginner or already comfortable with building servers, this video will give you a bird's eye view of how authentication and authorization work in web applications. So let's get started. A lot of the times people don't get clear idea of what's the difference between authorization and authentication. So what exactly is the difference? Let's see. Authentication, or AuthN, is all about verifying who you are. Think of it like going to a party. Before you enter, the bouncer checks your ticket to make sure you're allowed in. If you have the ticket, you are good to go. In web server terms, authentication means checking your credentials, like a username or password, to verify your identity and allow you to log into the system. On the other hand, authorization, or so-called AuthZ, determines what you are allowed to do. Let's say you get into the party, but now you want to enter the VIP lounge. The bouncer will check if you have a VIP pass on your ticket. Without it, you cannot go in. Similarly, this in web terms, authorization controls access to specific resources. For example, a regular user might not be able to access the admin panel because they don't have the necessary permissions. So authentication is about identity and authorization is about permissions. Both are important for keeping systems secure. Now let's move to what are the types of authentication based on state. State refers to how data is stored and maintained over time in an application. In simple terms, it's the memory of a system that helps it remember things between different interactions. Based on state, we can have stateful authentication and stateless authentication. Stateful authentication means the server keeps track of the user's data. When a user logs in, the server stores the session information like logged in time and its expiry, usually in a database, so it can recognize them in every request. In contrast, stateless authentication doesn't store user sessions on the server. Instead, it relies on tokens, like for example JSON Web Tokens, or otherwise called JWT, which the client includes in every request. The user verifies the token but does not store user session data. In the past, stateful authentication was the standard way of managing user sessions. This approach required the server to keep track of user sessions by storing session data in a database or server memory. So let's visualize this for a moment. For example, let's say a user logs in with their credentials, that is username and password. The server creates a session and stores the session ID in a database or memory. The session ID is sent back to the user, often stored in a browser cookie or something. On every request, the session ID is sent to the server, which checks the database to verify if the session is still valid. If the session is valid, the server processes the request, otherwise it rejects. Now, stateful authentication has some challenges. For example, every request requires a database call to check if the session is still valid. This adds latency on top of the request and makes the system slower under heavy traffic. If multiple servers are used as in a load balanced system, they all need access to the same session data, which complicates scaling. Sessions need to be cleared when user logs out or after inactivity, which adds more complexity. Because of this, to overcome these limitations, modern systems have moved to stateless authentication, primarily using JSON Web Tokens. Now, when a user logs in with their credentials, that is username and password, the server generates a JWT token and sends it back to the user. This JWT is stored on the client side. Usually it can be in local storage or in a cookie. For every request, the user sends the token in request headers. The server validates the token without needing a database lookup and processes the request. Stateless authentication offers a lot of benefits over stateful. The server doesn't need to store session data, reducing memory and database load. Now, since the token is self-contained, it includes all necessary user information, that is, the user can verify it without looking up the database. Since authentication is independent of single server, requests can can be handled by any instance in a distributed system. Tokens can include expiry time, user roles, and even can be revoked when necessary. Now, to summarize all the things that we talked about, stateful and stateless, we can say stateless authentication doesn't need any storage, like in stateful where we had to store session data in server and database and later look up the database for verifying request. And because of this reason, stateless authentication is faster and easily scalable as well. Now, the tokens also include expiry time, encryption, and revocation policies, and this reduces the session hijacking problem as well. Now that we understand stateful versus stateless authentication, it's clear that stateless authentication is the preferred approach due to its efficiency, scalability, and security. Over the years, various authentication methods have evolved to ensure secure access to applications and systems. Let's break down the most commonly used authentication techniques. The first one is username and password. Here the user enters a username and password to log in. The server verifies the credentials against stored user data. If correct, the user is authenticated and granted access tokens. This is the most simple method of authentication, you can say. Because of its simplicity, it is very easy to implement. We'll see how it's done in later videos. Now let's discuss the pros and cons of this technique. As I said, it is simple and hence it is widely used. It is also very easy to implement. Now in the cons, we can say if passwords are weak or reused multiple times, they can be easily guessed or leaked. Stolen database expose passwords if not stored securely. However, we can use different algorithms to hash the passwords before storing it in the database. We'll see this in future videos that this problem can be mitigated. There is also a high chance that users often forget passwords, leading to frequent resets. Now the second one is email and password. Similar to username and password, but here we use email as the identifier instead of a username. The user logs in using email or password. The server verifies the credentials and grants access tokens. Now this is a more user-friendly approach since people remember emails better than usernames, and it also works for account recovery as well because it is easier to reset password via email, but for this, email has to be correct in the first place, and because of this reason we add a verification step usually that verifies OTPs or a link. We'll implement this in upcoming videos as well, so make sure to subscribe. Now for this method, the cons are the same that we had in username and password authentication. We'll have security risks for reused passwords, and there can also be a high chance that user might forget the password. But then we have this account recovery process streamlined, so it mitigates that thing as well. Now recently we are seeing a lot of phone number and OTP verification methods. This is a more user-friendly method of authenticating a user because the phone number is unique to a person and it is considered to be more secure than an email. So here the user enters their phone number, they receive a one-time password via SMS or WhatsApp, the user enters the OTP, and then the server verifies it. If correct, the user is authenticated, otherwise it won't. Now the pros are it is more secure than just a password. No need to remember passwords. This is a major pro in this method of authentication. It also works well for password resets and account recovery, along with phone number, email, and password verification system if we take all together. Now the cons are attackers can hijack phone numbers and steal OTPs, and this is also not ideal for poor network areas where SMS delivery may fail. And other thing is users can be tricked into sharing their OTPs. This can also be a major problem in this method of authentication. Now comes modern authentication techniques, which is two-factor authentication, which requires two different authentication factors for login, which include something you know that can be a password and something you have, that is OTP or authenticator app or any security key. It can be anything. So combining these two things, we can have two-factor authentication that might include OTP via SMS or OTP via authenticator apps. We'll discuss these methods in detail in later videos, where we'll be using an authenticator app like Google Authenticator or Microsoft Authenticator for this time-based OTP method authentication systems. Now the pro is even if passwords are stolen, attackers still might need to pass the second factor, which will be either an OTP or some security key. So this reduces phishing risks as well. Now the cons are we are adding more steps during login, so which might be frustrating for some users. Now the last one we'll talk about is multi-factor authentication, which includes 2 or more factors for authenticating a user. So here we can have something which is a password, something you have, which is an authenticator app, let's say, and something you are, which is your identity unique to yourself. That can be fingerprint, face ID. So this is the most secure way of authenticating a user, but this brings a challenge of overwhelming the user with more steps during the process. So we should find the right balance between the complications in the process and the user experience. Sometimes people use multiple authentication methods simultaneously to mitigate the limitations of each. For example, many websites now allow users to authenticate using fingerprints or passkeys. Although this requires an initial setup, it eliminates the need to enter passwords or OTPs altogether, as fingerprints provide you a highly trusted and secure way of verifying a user's identity. I'll try to cover each of these techniques and concepts in more detail, along with its implementations in later videos. Make sure to subscribe for the updates. Now that we have covered authentication, let's move on to authorization, which determines what actions or resources a user can access after authentication. There are several authorization techniques used in web servers to control access, ensuring users only have permission to perform allowed actions. Let's explore these in detail. First is the role-based access system, which is otherwise called RBAC. RBAC is a static authorization model where users are assigned roles, and each role has specific permissions. Instead of assigning permissions directly to users, they inherit permissions based on their role. You can have different roles for users in an application. For example, in a blog application, there can be normal users who can just read the blogs, leave comments, like the blog, or subscribe a newsletter. Author users can write and publish blogs. Admin users can see the analytics, revenue and traffic, and also assign roles such as author. Once a role is assigned, the user automatically gets all the permissions associated with that role. Now the second one is attribute based access control, which is ABAC. ABAC is a dynamic authorization model where access is granted based on attributes of the user, the resource, and the environment. ABAC uses policies that check multiple attributes before granting access. These attributes can be user attributes that include role, department, clearance level, age, etc. It can be resource attributes, which is file type, sensitivity level, ownership, etc. And it can also include environment attributes, which is time of access, location, device, etc. Here, authorization is not just role-based, but also considers context and conditions. We'll see these things in action in later videos when we'll be talking about building an authentication and authorization system in Node.js and Express. With that said, I want to end this discussion here. You now know the ins and outs of various authentication and authorization techniques commonly used. If you are enjoying my videos and like me to continue uploading videos to this playlist, please leave a like and subscribe. It motivates me to put my efforts to bring you guys more informative and programming videos just like this one. That's it for this video. See you in the next one. Peace.